This is Teacher Abby, and for today's video, we're going to talk about the end term of geometric sequence. In this lesson, we need to learn the following objectives. For number 1, familiarize the formulas in finding terms of geometric sequence. Second, find the end term of a geometric sequence. Before we move on our discussion, let us have first our drill. In this drill, you're going to identify whether the following sequences are geometric or not. If it is geometric, give the value of the common difference. For number 1, we have 2, 8, 32. Number 2, 8, 4, 2. Number 3, we have 6, negative 4, and 8 over 3. Number 4, we have 4, 9, 14. And number 5, we have 4, 13, and 22. For number 1, as we can see, let us try to get if there is a common ratio. 8 divided by 2, that is 4. And 32 divided by 8, which is also 4. Since we have a common ratio, which is 4, then we can say that this is geometric sequence. For number 2, let us try to get if there is a common ratio. 4 divided by 8, this cannot be, so that would be 4 over 8. And 4 over 8 can be simplified or lowest term into 1 over 2. Now, let us have 2 divided by 4. So, that will be 2 over 4, which has also a lowest term that is 1 over 2 or 1 half. Since they are the same, therefore we have a common ratio which is 1/2 or 0.5. Therefore, this sequence is a geometric sequence. For number 3, let us try to get if there is a common ratio. That would be negative 4 divided by 6. That will be negative 4 over 6, which can be into lowest term, which is negative 2 over 3. Then, 8 over 3 divided by negative 4. That can be 8 over 3 times the reciprocal of negative 4, which is negative 1 over 4. Then 8 times negative 1, that will be negative 8. Then 3 times 4, that is 12. And if we're going to simplify negative 8 over 12, that would be negative 2 over 3. So, we have there a common ratio which is negative 2 over 3, and we can say that the sequence in number 3 is a geometric sequence. In number 4, we have 4, 9, 14. 9 divided by 4 is around 2 point something, while 14 divided by 9 is about 1 point something. Based on that, we can say that there is no common ratio. Therefore, this is not geometric sequence. And for number 5, 13 divided by 4, that is 3 point something. Then, 22 divided by 13 is 1 point something. Therefore, no common ratio. This is also not geometric sequence. Since we already know how to identify whether a sequence is geometric or not, let us review geometric sequence. It is a sequence where each term after the first is obtained by multiplying the preceding term by a non-zero constant called the common ratio. And it has a formula which is a sub n is equal to a sub 1 times r raised to n minus 1, wherein a sub 1 is the first term, n is the number of terms, a sub n is the nth term or last term, and r is your common ratio. Let us also remember that in getting the common ratio, we simply divide the second term by the first term, the third term by the second term, the fourth term by the third term, or the current term divided by the previous term. And now, let us have example. For example number 1, find the a sub 10 of the sequence 5, 20, 80, 320. Let us first get the common ratio. Again, in order for us to get the ratio, let us divide the second term by the first term, the third term by the second term, and the fourth term by the third term. So that would be 20 divided by 5, 80 divided by 20, and 320 divided by 80, which is all equal to 4. So our common ratio or R is equal to 4. And our given R, a sub 1 or first term would be 5. Our n is 10 since we're looking for a sub 10 or the 10th term. Our r is equal to 4. Then we're going to look for a sub 10. And the formula for our geometric sequence again is a sub n is equal to a sub 1 r raised to n minus 1, and substituting all the values from the given, that would be a sub 10 is equal to 5 times 4 raised to 10 minus 1. In this case, we're going to simplify first the exponent, which is 10 minus 1. That would be 9. Then, 4 raised to 9, meaning to say, you're going to multiply 4 by itself 9 times, which is equal to 262,144. Then, let us multiply this value to 5. That would be 1,310,720. So, that is the value of our a sub 10 or the 10th term of the given sequence. For example number 2, find the 9th term of the geometric sequence 2, 6, and 18. Let us find first the common ratio. That would be the second term divided by the first term, and the third term divided by the second term, which is 6 divided by 2 and 18 divided by 6, which is both equal to 3. So our common ratio is 3. And the givens are a sub 1, which is 2, the first term, n is 9 since we're looking for the 9th term, our r is 3, and we're looking for a sub 9 or 9th term. So using the formula, a sub n is equal to a sub 1 r raised to n minus 1, we're going to substitute the given values. That would be a sub 9 is equal to 2 times 3 raised to 9 minus 1. From here, we can simplify the exponent, which is 9 minus 1. That would be equal to 8. Then, 3 raised to 8, that would be 6,561 multiplied by 2, that would be equal to 13,122. So, that is our a sub 9 or the 9th term. For our next example, we have find the a sub 9 of the sequence 108, negative 36, 12, and negative 4. Okay, So let us find the common ratio. That would be second term divided by first term, third term divided by the second term, and fourth term divided by the third term. Substituting the values, that would be negative 36 divided by 108, then 12 divided by negative 36, then negative 4 divided by 12, which is all equal to negative 1 over 3. So that would be the value of our ratio. And our given are a sub 1, which is 108 as our first term. N is the number of terms, which is 9, since we're looking for a sub 9 or the ninth term. Our R again is negative 1 over 3, and we're looking for a sub 9. So using the formula, a sub n equal to a sub 1 times r raised to n minus 1, as we substitute the given values, that would be a sub 9 is equal to 108 times negative 1 over 3 raised to 9 minus 1. So as we simplify the exponent, which is 9 minus 1, that would be equal to 8. Then, negative 1 over 3 raised to 8, that would be equal to 1 over 6,561. Then we're going to multiply it by 108. 108 times 1, that would be 108 over 6,561. And since we can find another value for this as its lowest term, that would be 4 over 243, which is both divided by 27. So, 4 over 243 will be our ninth term or the a sub 9 of this sequence. And for our last example, let us find what is the seventh term of a geometric sequence whose fourth term is 128 and the common ratio is equal to 4. Based on the problem, the given are a sub 4, which is 128, because according to the given, the fourth term is 128. Then, the n is 7, since we're looking for the seventh term. Our r is 4, since the common ratio is equal to 4. And we're looking for the seventh term. But, if you're going to notice, the formula a sub n is equal to a sub 1 r raised to n minus 1, we have the missing value there, which is a sub 1. So, since we have the value of a sub 4, we can use this as a sub n, and our n would be depending also to the our a sub 4, which is 128. So, we can write that one as 128 is equal to a sub 1, 4 raised to 4 minus 1. Since we make as the a sub 4 as our a sub n, which is 128, and we're looking for a sub 1, our r is still 4, and our n would be 4 instead of 7 because we're using the a sub 4 or the fourth term. So that will be our n minus 1. So simplifying this one, that will be 4 minus 1, which is equal to 3. Then, simplifying 4 raised to 3, that would be 4 times 4 times 4, which is equal to 64. Then, we're going to divide both sides by 64 in order for us to isolate or leave a sub 1 in one side. That will be cancelled out, leaving a sub 1 behind. And 128 divided by 64 is equal to 2. Therefore, our a sub 1 or the first term is equal to 2. Now, from here, since we have the value of our a sub 1, we can now simply get the value of our seventh term. So, substituting the value, that would be a sub 7 equal to 2. Since our a sub 1 is 2, then our r will be 4, and our n will be 7, since we're looking already for the seventh term, minus 1. 7 minus 1, that would be 6. Then 4 raised to 6, that would be 4,096 multiplied by 2, which is equal to 8,192. So that would be our 7th term, or a sub 7 of the given sequence. Since we're done with our example, we're going to have your activity. In this activity, you're going to find the specified term of the given geometric sequence. For number 1, we have 3, 6, 12, and we're looking for the 7th term. Number 2, we have 18, 16, 18, 6, 2, and we're looking for the 9th term. And number 3, that would be 1, 1/2, and 1/4, and we're looking for the 7th term. And that's all for today. If you have questions, you can message me via Facebook Messenger, Abby Mendoza. Thank you for watching!